Good afternoon. This actually isn't a routing test project at Avici, but just a general call to the way core routers should be tested. As an outline, there's just three major areas. First, we're going to do a review of how to measure IP network availability, and then the test coverage to actually test to achieve 5 nines of availability, and that what we need the commercial test equipment vendors to do so we can actually do that testing. So availability. First, let's realize why availability is important. Reliability means more revenue. Research from Telechoice, they actually did a survey, shows that the number one reason customers select a network is reliability. More reliability means more profit. As I mentioned yesterday morning, right now in the IP networks there's a need for redundant routers, and that's not done in other networks. So some definitions as we get into the detail here. Reliable, capable of being dependable, as defined by Webster. So is your router reliable? Is it capable of being dependable? Is it like your best buddy? Availability is a measure of reliability using router and switch uptime. Mission reliability is the mean time between critical failures. That's different from maintenance reliability, which is the mean time between failures. So say a protocol software bug, that would be maintenance reliability. Mission reliability is something that affects availability. It actually brings the router down during operation. It affects the SLAs you've promised your customers in writing. Contributing factors for availability. There's, of course, the mission reliability, crash dump time, which hopefully is quick, image upgrade time, sometimes not necessary, boot time, which is inherently required here, and protocol convergence time, which has become so important to all of us and certainly is a key focus of the industry right now. For hardware, it's similar. You get the maintenance reliability, maintainer response time, removal and replacement time if required, then the boot time and protocol convergence time. So the availability goal, 5 nines of router availability. Right now it is, in fact, as measured by your reliability department, 3 nines. Now, features that vendors, router vendors are putting in to achieve the 5 nines are the stateful failover, the non-stop routing, and then also the IETF solution, graceful restart, even though there's still some question if that actually achieves 5 nines of router availability. So the question I'm posing here and hopefully answering is, what if testing could be done on routers today to achieve 5 nines of availability in absence of those features, the non-stop routing and the graceful restart, and then addition of those features actually achieved 6 nines of availability? I actually think it's possible, and I'm going to go through a test program that I think works to get that. I hope you all agree. As I'm sure all of you know, testing is never done, right? You can go on testing forever. So if anyone has inputs on that, ways to improve the testing, please let me know. So the test coverage. Traditional test coverage has been on isolated testing of protocols, the functionality, conformance, interoperability, scaling. And then the forwarding performance has been done in the absence of protocols. Well, guess what? That's not the way the router is used in your network. The disadvantages of that then is the operational environment is not tested, operational conditions are not tested, and your router isn't really stressed. Scaling testing is not stress testing. So deployed routers run multiple protocols simultaneously. That then is the way we need to test routers, running multiple protocols simultaneously with traffic forwarding. So what is the test program to do that and therefore verify 5 nines of availability? I believe it includes 5 key components: stress testing, longevity testing, convergence testing, network-specific topology testing, and automated regression testing. So I'm going to go into each of these. Stress testing requires simultaneous configuration and scaling of multiple protocols with traffic forwarding. Then you induce network instability. Repeat BGP route flaps, cause link loss, force tunnel reroutes, and while doing this, service the box. Repeatedly do SNMP gets, enable logging, enable debug, do show commands. Do tough show commands. Show running config, show IP BGP with 100,000 routes in the BGP table. With all of those protocols running, all of them scaled, line rate forwarding, and the route flats and the link loss. So what would a stress configuration look like? Down the bottom in the yellow, you see the test equipment. There's 3 boxes there. Hopefully we'll get to a point soon where that's actually 1 box. And in the center, you'll see the router under test. That's actually bolded. An important part of the stress configuration is to have neighboring routers. That way you can verify interoperability and also induce other protocol conditions. The top box, the one labeled optional, is in fact optional. That one's for tunnel reroutes, if in fact you're interested in doing fast reroute or standby LSPs. So what are some good guidelines for doing for executing stress? Well, configure ECMP, parallel paths, or composite links. Use a live BGP feed. That does make a difference. You can make up your own route table, but there's nothing like testing with the real route table. Mixed traffic types. At the same time, on your data plane, have IP unicast, IP multicast, and MPLS. That, of course, will force you to have all those protocols running on the control plane. Make sure to use a different vendor in the stress config. That shows that under stress, you're still interoperable. That matters in your network because under stress, your router will still have to be interoperable. And then run this for many days. It can get ugly, but hopefully over time, it won't be. So what are some typical stress metrics? Well, these are per hour. And I'm not crazy. This is the way these should be tested. Flap 1 million BGP routes per hour. Forward 10 terabits of data per hour. Perform 100,000 SNMP gets per hour. Simulate 100 fiber cuts per hour. And of course, you can increase all of these if you dare. Along with all that, have a full BGP table. Live feeds usually the best thing. Have the maximum number of route instances as well. Have IGP run with a full multicast cache. Have your required number of MPLS-TE tunnels configured and your required number of LDP FEX. With all this going on, enable logging and protocol debug. Yeah, I'm not kidding around. I'm saying under stress, do all that. Enable the logging and protocol debug. So longevity testing, it's slightly different from the stress testing because you're going to run in more operational conditions. You're going to bring down your scaling numbers to more operational conditions and run very similar tests over time. Be sure to use the live feed when doing this. All right, now let's jump into the third component of this, and that's the convergence testing. So there's 3 different terms for convergence that get thrown around, and they kind of get mixed up. So let's just clarify here where we're going to focus. So network convergence is the point in time in which all nodes in the network have updated their routing tables, versus protocol convergence, which is the time in which a single node updates its routing table and advertises the change to its peer. And then the third one, which is route convergence. That's the point in time in which a single node updates its routing table and reroutes traffic out the new interface. That term, route convergence, is the one that's actually been used in labs as the benchmark to evaluate convergence performance of a router. So what are some test issues with convergence? Well, of course, there's a large number of protocols in which to test convergence, so this can go on for many weeks. There are a lot of conditions that can impact results. We'll hit those on the next slide. And then there's, of course, technical difficulty in doing this because you want to test convergence when there's instability of one protocol impacting another protocol. So the test equipment needs to be able to closely control that and monitor that to make the measurements. So what are the test conditions? So, you've heard especially yesterday, there was a lot of talk about convergence and some vendors saying, our convergence is awesome and, it's better than those guys. Be sure when you're testing convergence in your lab that you test all the conditions because you will get different results when you force the convergence. First one is interface shutdown. Do it on the local interface, do it on the remote interface. Fiber pull. Yeah, you'll get a different result in interface shutdown. And make sure you do it on the local and the remote interfaces. Do peer removal via the CLI. Yeah, take the whole peer away. Actually force a node failure. Power down a neighboring peer and measure convergence. And then, of course, there's the convergence times due to route table changes, and there's many of those. Route withdrawal, route flap, next hop change, metric change, dynamic constraint change, and even a policy change. I'd be wary if your router vendor is telling you to pick one or two of these and that's the way to do the measurement. That usually means that the other ways the result is not as good, so make sure you do complete coverage in your testing. Network-specific topology testing. This is really important because when it comes to deployment, you want it to work on day one. So it's important the router vendor and also the network provider do testing that's topology-specific. A good network would include 10 routers with multiple vendors in it, and of course multiple protocols actually configured in a deployment scenario, and then run through actual deployment scenarios. Failure conditions you've seen in your network, test those before actually deploying. So the fifth component of this test program is automated regression testing. Regression testing is critical because over time we're adding, the router vendors, we're adding bug fixes to our images, and of course we're adding the new features that you demand. For each release, as we add this new stuff, it impacts the operation of the software from the previous releases. So it's critical to go back and always check and make sure that the way things have been working in your network are the way things will still work in your network when the new features are deployed. Now what that means is over time, ultimately over years, there's a lot of stuff to go back and regression test. So the only way you're going to get through all that and do full coverage is to automate the regression testing. Actually, let me just point out, for automation of regression testing, there's just a basic configuration that can be used. It's actually one the test equipment vendors have been working with as well. Right down the bottom, the gold box is the test equipment and a single router under test. So the test equipment actually emulates a larger network. That way it saves you a lot of money from having to build out a large network to do the regression testing. Have the test equipment trick the router under test and make it think there's a big network out there when there actually isn't. That will help save money with the automated regression testing. Having done that, the test equipment vendors are actually now building TCL-based conformance suites to do this testing. So now, having reviewed the 5 components of a test program to achieve high availability, let's actually look at the commercial test equipment requirements. What is the state we're in now? I actually believe, after getting much input from all the test equipment vendors for this presentation, no single piece of test equipment actually meets the requirements to do all this testing. As a result of this, router vendors such as Avici have been forced to develop our own internal tools. And what that means is the network providers, when they're doing certification testing, have to use vendor-developed tools or even develop their own. That, of course, is not the business we want to get into. It's important that test equipment vendors provide the test equipment features that we need today so we can get out of the internal test development programs. So what are the requirements for the stress testing? Test equipment needs to be able to maintain BGP sessions and IGP sessions simultaneously. Flap BGP routes, signal and maintain TE tunnels, distribute LDP FEX, signal and maintain the multicast groups, perform SNMP gets and check validity of those objects, and at the same time forward traffic, unicast, multicast, and MPLS, all at the same time to the FEX that are in the network on the tunnels and also to the BGP routes that are in your route table. Everything needs to match up so you can truly do a valid test. And what this means is the test equipment is going to make the network seem much bigger than it really is. The protocol emulation and conformance suites. This gets into the automated regression testing that's available on the test equipment. So the conformance suites is the automated regression testing piece. The other part is the protocol emulation which you use in the stress testing or the longevity testing. That's the piece of the test equipment, the software on the test equipment, that actually brings up sessions and maintains them while you're doing the testing. It isn't actual directed conformance testing, but a very important piece of testing. So for both of those, the emulation and conformance, we need BGP, OSPF, ISIS, the IGPs with the extensions, RSVP-TE with support for fast reroute, standby tunnels, and the ingress, midpoint, and egress. LDP, we need 2547, layer 3 VPNs, Luca Martini, layer 2 VPNs. We need support for P and PE with those implemented. And of course, LDP over RSVP. That must be on the test equipment as well. And then the last piece, which has kind of been forgotten by what I'll call the three primary test equipment vendors, multicast, MBGP, PIM-SM, and MSDP. I'm sure people who have wanted to test multicast have been disappointed with the offerings from the three top test equipment vendors, Agilent, Spirent, and Ixia. But hopefully some people from those companies out in the audience will nod their heads and say, yeah, we're going to do something about multicast, because that's getting deployed. Good. Thank you. Protocol emulation requirements. We need to be able to run any protocols in combination on the same interface. We need to forward traffic for the emulated protocols. That creates valid tests where the traffic actually matches up with routes in the route table or tunnels. We need the protocol emulation to work on any interface type. We're tired of restrictions of which interfaces we can run the protocol emulation on. It's good to have it work on all interface types. The scaling needs to get much better. We need to have greater than 500 BGP sessions, even as many as 100 for a single interface. For BGP routes, we need to be able to emulate 3 million for the system, even 500K for a single BGP session. And then TE tunnels, we need 10K or greater with support for ingress, midpoint, egress, and then the FEX have to be over 10K. One feature that one test equipment vendor does have, and I don't want to show favoritism, so I won't mention who, but I think it's a great feature, is you can actually load externally a BGP table for advertisement for the BGP emulation. I think that's an absolute requirement. That way you can actually take a dump of like a show IP BGP and load that output right in from a file, and that's the route table it will use for its protocol emulation. I think that's a fantastic feature. And then also we need more tightly controlled BGP route flapping so we can go on with our stress testing. Automated regression testing requirements. As I mentioned, the commercial test equipment vendors are offering the TCL suites. I'm still a little nervous about using them. First off, the coverage doesn't seem as good. If you took your test plan for a single protocol and compared it to what was available, you'd see that there were still a lot of test cases you needed to run through yourselves that weren't supported. So the test case coverage definitely needs to be improved. One thing that's lacking in the TCL suites from the test equipment vendors too is interaction between protocols. Like I was mentioning, we never run in an isolated protocol environment. So we need testing that has multiple protocols running simultaneously and then have automated pass-fail measurement when one protocol impacts another protocol. And another thing is we need the scripts to test multiple interfaces. It's not sufficient to do protocol testing on a couple interfaces. We actually need to emulate a larger network, so we need 4 or more interfaces actually tested when we run the scripts. And of course, we need the full protocol coverage. And again, I mentioned multicast, the forgotten son. And then the last slide for the requirements for the test equipment vendors are the system requirements. As routers are getting more dense with number of ports, the test equipment vendors need to keep up. And it's not realistic now to think that one test equipment box that has less than 20 interfaces is sufficient for testing a core router. I put the number 32 here. In fact, I think I'm being too conservative. I think it needs to be a lot larger than that, probably double that, 64 if not higher. Automated convergence measurement. We've all been talking about how important convergence is now. Wouldn't it be cool if the convergence measurements were actually automated so we didn't have to think too much about it? There was just some standard procedure which it was done. That was the way the test equipment vendors did it, and we could just press a button and go and then get our output for the time. We need automated reroute and failover measurement for MPLS. We need support for ECMP and composite links. Those are deployed in real networks. It would be great if we could test forwarding with those and also with protocols being emulated over those. Then, of course, for the stress testing over many days, we definitely need system and protocol stability. The test equipment needs to be as reliable as the routers under test. They just need to stay up when we're doing all this stuff over many days. We need the ability to store a GUI configuration for repeatability. And we need the ability to write a TCL script for any GUI test case. So a lot of us, when we do our testing, we do it in the GUI first, and then we want to go off. After perfecting it in the GUI, we want to automate it via TCL. We want to make sure that everything we come up with in the GUI is, in fact, automatable in TCL. So that is all I had for core router testing for high availability, and I'd certainly welcome any questions at this point.
Hi. So a lot of that's a nice wish list, and, you know, I agree with a good portion of it. Some of it I don't really have any insight into. But I'm still hung up on something you said at the very beginning.
Okay.
You said you saw a survey, and the survey said that customers buy based on reliability.
Right.
I'm wondering why you didn't laugh at that and go find somebody who was actually able to get truthful answers out of customers. I mean, do you believe that? Do you believe that customers care about the difference between 5 nines and 6 nines reliability?
Do you have an SLA? Are you a network operator?
Yes.
Do you have SLAs for your customers?
I've tried it in the past. None of them are willing
So you
to
don't
pay
anymore.
any
I would
money
say,
for it.
Excuse me?
None of them are willing to pay any money
For
SLAs.
Right, but is it written? Do
Yes,
they have a
I've
contract with a guaranteed SLA?
Yes, I've done those in the past. It was a bad idea because it doesn't make any money. Because
Right,
customers aren't willing to pay for reliability. Customers are interested in price.
In what?
Price. They'll buy the cheapest service they can get. Then,
Are you a router vendor?
Yes, I am. I'm from
Have you ever sold a product with SLAs to people? Have you ever sold a product with SLAs to people?
Am I allowed to speak specifically about Avici? Okay, I will answer that question. In fact, last week at Supercom, Avici made an announcement that we are, in fact, guaranteeing in writing 5 nines of the availability of our router in any network.
With credits, service credits?
Absolutely.
Awesome. No, I'm very impressed, actually, truthfully.
Yeah, because we believe in it.
Okay.
And as test manager, let me tell you, I'm confident in it.
Okay, I'm not sure you should be, but I'll get to that in a second. But, because we were just having a conversation out in the hall, which is sort of the, let's do, settlements on peering. Just tell me which direction, it has to go, and I'll just go retire after I collect money for a couple months, either pulling or sending traffic. With SLAs on routers, I question whether, I think this is all really good stuff. I don't think it goes far enough for what you'd need to be able to issue service credits, in other words, refunds on pieces of routers.
All right.
And I think I'm going to speak for Bill, for the channel Bill, a little bit, and just say my own feeling is that empirically I see providers asking for new features and new protocols, and not saying I won't buy your box unless you give me an SLA, which is why for the last 10 years router vendors haven't given SLAs, because if everyone said I won't do this unless you X,
Right.
and I think that's why a lot of people in the provider community are suspicious of any assumption that the people who buy routers, care deeply about reliability.
Yeah.
Anyway, so that was
but there's a few points to be made
Okay.
there. I think the reason is that demands haven't been made on availability of routers is over the years, network operators have just come to the realization that routers suck.
Yes, we know that, but there's
Yes.
some people who do try to base their purchases primarily on or more on robustness, and then there are other people, networks, whatever, who clearly want features because they think that drives revenue and not robustness. In other words,
Right.
people will pay for converged, I can save money with converged network, or people will pay for this VPN service that I can offer to them, versus people will pay for SLA,
Yeah.
which I think has been, an issue for everyone.
So a major carrier will operate multiple networks, so if an IP network, a voice network, an ATM network. And quite often the CEO is going to the guys who run the IP network saying, why aren't you as profitable as the other networks? Why are we getting more customers for the ATM network? Why are we making more money on the ATM network? And the reason for that, it goes right to the points of reliability actually being the key. The reason major carriers now are selling more ATM service is it is more reliable right now. So it's time the router vendors change that.
Wait, yeah, it's different. Okay, so let's just try a test case here. Let's say I'm a carrier, and like many carriers, I'm selling for $39.95 a month a DSL service that costs me about $300 a month to provide. Let's say I make it more reliable.
Yes.
Okay, so now it only costs me $450 to provide.
Yeah.
Okay, how much more is the customer going to pay for that?
Yeah. So you're missing the point. The reason you're charging $39.95 is not to compete against the other IP networks. It's to compete against those other more reliable networks. Okay. If it's more reliable, you will get more customers and more revenue, and there will be more demand for your network, and you can charge a higher price.
If you have faster access to porn, you'll have better...
Wait. If it's more reliable, I can charge a higher price?
That's right, because you can have higher SLAs. Right now, you're offering lower SLAs on your IP network. Are you offering the same SLAs on your IP network and your ATM network?
The problem with
Or your
DSL
voice
is the pair, which, I mean, the problem is the telephone companies.
Yeah.
I mean, he was using, as you know, network operators do, he was using a degenerate case. I use an overloaded operator, but let me back off from it and say, I think that if there's a vendor who's offering a money-back guarantee on a piece of the router, if there's a catastrophic failure, that's an awesome thing.
Right.
And I actually am thinking of business models to make lots of money right now. But as an entrepreneur. But the one thing that I would say is, and this ties to it, I've often thought that, you know, there's a lot of creativity that the teenagers and malcontents seem to have about how to send malformed multicast packets that crash, you know, every Cisco in my network, or how to exacerbate some problem, or the notified behavior in BGP, how to tickle that by releasing malformed updates that some vendors parse one way or another. And I think there's another dimension, which is to get truly evil with what people like me would actually do to get money back as a consultant, you know, get money back for people who buy your devices.
Yeah, particularly you.
Right, if you have an SLA, is to really think about all the degenerate cases around these protocols, which is really where a lot of the attacks come from, is not just playing, you know, what the show IP BGP was, but try to figure out, you know, have people do code review, pay bonuses to people who are really think evilly to do this. That's just my advice, is that people who have an engineering background often aren't capable of enough creative evil to really exercise a lot of cases here. Yeah. And I think that will actually be important if you have an SLA. And again, in all seriousness, I applaud that. I think that's really great, having an SLA on a rack.
Thanks, and I think you made an excellent point, and I think it's one that should be recognized. Any other questions at this point? No? All right, all set.